Hey, hi, my friend. So here I am, Srinivas Belvi. So with a lecture on the percentages, I will talk about the importance of the percentages. Especially, there are three fundamental concepts in percentages, so which everyone should kind of be aware. Those who are preparing for any aptitude exam, right? Be it you are preparing for BBA, be it you are preparing for CLAT. In fact, even if you are preparing for your MBA, doesn't matter. In this entire space, this is one of the very foundational topics. So here, let's get started on this. Uh, Okay, what is the scope of this particular chapter? It is not just limited to percentages, which means not that direct applications or direct questions come from the percentages, but yes, you do have prominence with respect to profit and loss. So there is a complete connection. You can say that, okay, if you are good with percentages, you might as well feel profit and loss is pretty manageable, right? And then you have the references to the more than simple interest. Yes, of course, simple interest, but I'm definitely saying that, hey, the compound interest, which is between the two, simple interest and compound interest, a lot of people think that compound interest is a bit trickier. So this can be resolved much more faster if your fundamentals of percentages are good, or some of the techniques we learned today in percentages are good. And of course, already it has a huge bearing on the questions which come from the data interpretation, especially in the field of the graphs, right? Be it a tabular representation of data, or be it line graph, be it pie chart. It has a huge bearing in that particular area than I could say the reasoning based DI, right? Which is, I'm talking more about the calculation based DI. So this is, therefore you may say that, hey, there are direct benefits, which means there are questions which can be directly flying from this particular chapter. There are a couple of questions belonging to a particular some models, so direct from there. Or you may understand that, hey, there is a indirect bearing of this particular chapter, the influence, or there is an influence of this chapter on profit and loss. It could be simple interest, compound interest, data interpretation. I'm not ruling out the option that it doesn't have a bearing on any other chapters, but yes, it has a significant bearing on these chapters. Fair enough. We talked about, hey, there are two or three aspects that one should know, all right, with respect to the percentages. Even before we get on there, so let me help you to understand that, hey, not just even before that, the speed at which you calculate certain calculations is important. Therefore, must know, since all right, now this could be one of the fundamental lectures, all right, that you could be attending, so therefore, from that perspective, when you see, so it's a couple of things. If you have ignored the tables till 20, I would rather recommend you must know your tables till 20. When I meant tables till 20, I didn't mean that 20 cross 20, I mean 20 cross 10. All right, that is 2 cross 1, 2 cross 2, likewise up to 2 cross 10. Then already you move on from 20 cross 1, right? From here you move on to you move on to 20 cross 1, 20 cross 2, likewise up to 20 cross 10. Right, so this is important. Having a control over the tables, being in touch with tables would definitely enhance your speed at which you can think about certain numbers, the speed at which you can calculate certain numbers. Therefore, never neglect the tables. Second one, some techniques of speed calculations would definitely help. I'm not saying that, okay, you should master that entire Vedic mathematics. I didn't mean that. So there are a couple of techniques on multiplication, the squares and the division, finding the square roots. That would definitely help in certain approximations, right? Especially already, if not anything, already you should know certain techniques on multiplications and squares for sure. And if time permits, definitely it's advisable to learn few techniques on divisions and square roots as well. Coming to this, all right, now, so this I'm not touching on this. These are two different areas, right? I'm more talking about the percentages. Therefore, what are the must know things in percentages? Percentage fraction equivalent is must know, right? In the sense, whatever people speak as percentage, for us it's nothing but a fraction. Therefore, percentage fraction equivalent is kind of a key which we all should kind of know. Percentage fraction equivalent is very important, so I will rather start there instead of taking it for granted. Okay, you understand what I meant by this, so let us make inroads from there. Here we go. Percentage fraction equivalent. What I meant by that very word, what I meant is, so if there is 1 by 2, 1 by 2. 1 by 2 is 50%. As we all know, the 1 by 2 is 50%. Right? So that is 1 out of 2. Somebody scored 1 out of 2 marks. What is that? That's 50%. Right? So what is 1 by 3? When we write 1 by 3, we can write it as 33.33%, or you can also call it as 33 1 by 3%. Choice is yours, whichever way that you remember. That shouldn't really matter, right? But this is what 1 by 3 is. Similarly, 1 by 4, when we write, we call it as 25%. So what is the black box here? If you see from that perspective, okay, so 1 by 2 is 50%, that's fine. What is the black box? Black box is this: 1 by 2 into 100 is equal to, this is the black box. You're technically doing this calculation in a sense. 1 by 2, 2 one time, then 250 times. That's what you are writing it as a 50 and applying this particular sign, the symbol there. So if you want to understand it a little better, what is this 50 percentage? Percentage is a symbol. As much as factorial is a symbol, percentage is also a symbol. So when I say, I'll know 5 percentage or 5 factorial, it means something. What is 5 percentage? It technically means 5 divided by 100. That's the meaning of the percentage. And what is 5 factorial? That is nothing but 5 into 4 into 3 into 2 into 1, or 2 into 1. So that's what we mean by 5 factorial. So when I write 5 percentage, mathematically it means 5 by 100. You can simplify and call it as 1 by 20. That is fine. Similarly, when I meant 5 factorial, I meant that product of first 5 natural numbers, which is nothing but 120. So it's a symbol. Technically, percentage is a symbol. So when I write x percentage, it stands for x divided by 100. All right, that is what it kind of stands for. Okay, so coming back to this is a black box. For me, what is important? The transition. When somebody says 1 by 2, am I able to write it as 50% quickly? That matters. Or if I see 50%, will I be able to quickly write it back as 1 by 2? Or it would be paramount. That would make a lot of sense. All right, similar way, when you write 1 by 3 into 100 technically is equal to, if you do this calculation, that is 1 by 3 into 100, so that would technically become 33.33%. but this is the black box. I will not write all this transition. In the sense, when you see 1 by 3, you should recall 33.33%, or when you see 33.33%, you should be able to represent it as 1 by 3. Either ways, the transition should be clear. Hey, likewise, still where I should learn, right? It is good to learn till about 1 divided by 25, which would become 4%. Alright, which can be represented as 4%. It is good to learn till there. There are several techniques by which you learn, but really doesn't matter. It is so foundational that you must, this should be at your fingertips. There is no second thought about it. Hey, is there a way to remember? Should I do it in this technique, that technique? Doesn't matter. It's as good as a 2 table. So for a 2 table, 3 table, 4 table, do you really want a technique? No. It should be already now so well understood, or it should be at the it should be so well drilled in your mind that at any point in time you are able to tell the tables of 2 3 4 5 10 20 whatever, right? So in the similar fashion, right, so these numbers should be so well drilled that okay, you don't need to link it with certain things, etc. It should just pop up, which means when I say 1 by 13, so you should simply write it as 7.69%. generally we remember to 2 decimal place accuracy, right? Whatever be the number, hey, suddenly you say that, hey, what is 1 by 7? All right, 1 by 7, 14.28%. All right, likewise 2 decimal place accuracy, remember up to 2 decimal place accuracy, it does has a significant bearing with respect to your percentage calculation, right? What are the things you should know? What are the things? All right, so if you have little more time, probably you can go you can do this homework even little better, so that, trust me, all right, because it's not from one chapter we are talking. All right, we are technically talking this from percentage, profit, loss, discount, right, SI, CI, data interpretation, right? It has so much, it's a huge space, in the sense like when you look from the aptitude test perspective, it is not just about 2 questions, it is this whole bunch of these particular questions which depend on this particular skill. So it is worth spending the time, maybe worth now learning few skills out here. Now, what are the thing? So it's better to learn something like this. Learn 1 by 2, learn 1 by 3 and 2 by 3. learn 1 by 4 on, you can learn it only for the relative prime numbers. You don't co-prime numbers, you don't understand what is co-prime, don't worry. So learn all of this: 1 by 4, learn 2 by 4, learn 3 by 4, right? Learn 1 by 5, learn 2 by 5, learn 3 by 5, and learn 4 by 5. You may be wondering, why not 5 by 5? 5 by 5 is 100%, which we all know. Yeah, so likewise, see, what I meant is, hey, 1 by 2, when you do 1 by 2, when you do 1 by 2, you're talking about 50%, 33.33%, 66.67%, that is 2 by 3. 1 by 4, 25%, 2 by 4, 50%. Now 2 by 4 can also be simplified as 1 by 2, but I said that you can do it only for relative primes, but that's okay. I'll let know one number here and there repetition, it's all right. Yeah, 3 by 4, 75%, 1 by 5, 20%, 2 by 5, 40%. This would somewhere help. Now the point is still where, right? When you do this, you try and do up to 1 by 12. You try and do up to 1 by 12. 1 by 12 going, that's 1 by 12 is 8.33%. All right, going up to 11 by 12. All right, going up to 11 by 12, all right, which is 91.66% or 67%. This would certainly help in majority of your calculations, right? Assuming that, okay, I'm not asking you to do it right now, right away, but keep this orientation in your mind. So take your book, take a pen, and then somewhere like, write and practice. So some of them may appear a little trickier. See, when you are doing 1 by 5 series, it's fine. But when you do 1 by 7 series, remembering to 2 decimal places might appear a little trickier there, but that doesn't matter. It is worth that effort. I would like to go through this particular series. There are a lot of techniques, but the idea is I don't want to deviate much from there. See, for example, if you want to learn 1 by 7 series, just to tell you all, maybe 2 or 3 are some niceties out here. So 1 by 7, if you want to write it, this is 1, the 1, 4, 2, 8, 5, 7. So if you want to write it, and then cycle repeats, this is called as a recurring decimal. Now let's not get into what is this recurring decimal. So let's say that, okay, this is 1, just remember 142857. Let's say, just remember this 142887. Just remember, whenever you recall 1 by 7 series, remember 142857. So for example, you want to find what is 1 by 7. In your mind, what you do is do 10 by 7. Take the first quotient, 7 ones are. All right, look at the first number, 7 ones are. When you get this, what you do from here is, now go to this 7, right? Go to this 1, right? Here there is a 1. Go to this 1, right? 4 digits from there. 1, 4, 2, 8, and put a decimal place and a percentage. Therefore, 1 by 7 is 14.28%. Fair enough. Let's say that I want to understand what is 2 by 7. All right, let's say I want to now understand what is 2 by 7. 2 by 7. Do it 20 by 7 in your mind. That's happening in your mind. 20 by 7, right? The first value, first quotient, first part, first digit of the quotient. All right, therefore you say that 7 twos are 14, right? 7 twos are 14, just twos are 14, because 7 threes are 21. So when you start dividing it, twos are, which means start from here, That's, you will write this as 2, right? 2, 4 digits there. 2, 8, 5, 7. Write 4 digits from here. Here 2, 8, 5, 7. That's what you kind of write. Okay. So when do I do the 3 by 7? If I'm doing it as 3 by 7 here, right? 3 by 7. So when you're writing 3 by 7, in your mind, take 30 by 7, right? 7 fours are 28. Therefore, the first quotient here is going to be 4. First quotient, my friends, 7 fours are 28, which means start your cycle from 4. If I'm starting cycle from 4, where I should start? From here, 4, 2, 8, 5. So write them 4, 2, 8, 5. Put the decimal place after 2 digits, right? First write the first 2 digits, which means refer there. So that's how you kind of do it. Likewise, you can develop this particular cycle as well, right? And there is another interesting cycle. I hope you got the idea behind this, rationale behind this. You can continue in this fashion. There is another cycle. 1 by 9 is also a pretty interesting cycle. You have a couple of interesting cycles here when you are trying to learn this chart. When you are trying to learn this chart, there are a couple of interesting cycles. Okay, let me clear this board. Yeah. Say, let's say you want to learn 1 by 9 cycle. What do you mean 1 by 9, 2 by 9, 3 by 9, 4 by 9, and so on. So you want to learn this particular cycle. 1 by 9, remember it is 11.11%. Pretty good. So when you are doing 2 by 9, you double this, 22.22%, just like a tables of 2. right? When you're doing 3 by 9, all it's nothing but 33.33%. When you're doing 4 by 9, it is 44.44%. Right, and likewise, all right, now likewise you can keep doing this particular table till 8 by 9, which will become 88.88%, right? So pretty simple one. Same way out here, so it's cousin brother 1 by 11, right? Its cousin brother is 1 by 11. So 1 by 11, you write it as 09.09%. Right, that's his cousin brother. So when you want to write 1 by 11, write it as 09.09%. When you want to do 2 by 11, multiply by 2, or you have either side of the decimal place. Either side of the decimal place, multiply by 2. 9 2s are 18. 9 2s are 18. Therefore, 18.18%. Right, when you want to get 3 by 11, again multiply. Go back to this as the reference stage. 1 by 11 as a reference stage. Multiply both sides by 3. 9 3 times 27. Therefore, 27.27%. Right, so likewise you can create it. So that's easy to remember. 1 by 9, 1 by 11, 1 by 7. Likewise, try and identify. There are certain patterns for most of the numbers. I've shown it for a couple of these numbers. So all said and done, the bottom line, whether which way you want to remember really doesn't matter, but knowing this particular chart is paramount. If you know it this way till 1 by 12, 1 by 12. So, and then if you know it, all it now, so vertically, all it vertical strip, this vertical strip up to 1 by 25, it would definitely do loads of good for you. All right, let's go further. So these are the must know factors. What I did is a must know factor just to illustrate that how does it really help. All right, just to understand that how does it really help. Think of this. Once you know these kind of percentages, just in case they try to outfox you with some of these kind of numbers. I'm not saying that every time they use these kind of numbers, but yes, I cannot rule out the option that such numbers do not come in the exam, right? Such numbers do come in the exam. So when you look at 25% of 164, if I know this 25%, you would rather quickly write it as 1 by 4 times of 164. Division by 4 is very easy. You would have got the outcome as 41. Similarly, 14.28%. See, being distant from this will not do any good for us. So 14.28% on the face of it, or it looks pretty intimidating. So it's what is 14.28% calculation. But the point is, if you know percentage fraction equivalent, 14.28 is simply 1 by 7. 1 by 7th of 147, right? So therefore, division by 7, nothing but knowing the tables of 7, which would have become 21. Likewise, when you look at all it 16.67%, which is 1/6, all it technically, this whole thing can be written as 1 by 6. We already learned that from the previous slide. That is percentage fraction equivalent. I'm assuming that. Okay, so today you might not know right now, in case all right, if you're not learned it before as a part of your school or a college or as a part of any of your preparation, you might feel little awkward the moment I'm writing 16.67% as 1 by 6, but that is the truth of the matter, right? So by tomorrow, even you would be able to write it like this, right? 1 by 6th of what? 624, all right, which would become 104. It becomes easier because all you need to know is what? Tables of 6. Now take a look at this 7.69%. On the face of it, it doesn't look pretty appealing. It doesn't look very nice number, right? 7.69%. So nothing but 1 by 13. See, this whole thing, 7.69 percentage can be written like this. What do you mean? What I meant here, right, what I meant here is 7.69 divided by 100 is nothing but 1 by 13. When you simplify this, it is ultimately equal to 1 by 13, right? 1 by 13th of what? 403. So therefore you should know the tables of 13. You can't say that, hey, I kind of struggled to recall the tables of 13. No, if you're learning this percentage equivalent chart, it is good to know tables till 20, right? Yeah, so therefore you will say that 33 3 times and 13 one time, 3 times. Our result is 31. So now again 83.33% looks very intimidating. 83.33% doesn't look like a doesn't look like a pretty good number there. But yes, I asked you to learn this. Hey, learn 1 by 6, learn 2 by 6, right? Learn 3 by 6 and so on. So when you are learned up to 5 by 6, so naturally your memory already will pop. This will come out. Hey, a 5 by 6 is nothing but 83.33%. From that perspective, if you learn few numbers like that, as I told you before, it would be really beneficial. Therefore, you could simply write this as, hey, this is 5/6 of 900, right? 5/6 of 900. 6 one time, So 150 into 5, which would technically become 750. That is the result. Okay, you might have understood how some of the not so good numbers, which means on the face of it, they don't appear nice numbers. See, 25 appears to be a good number. So 25% of something looks pretty encouraging because it appears good number. 20% might appear to be a nice number. But if you get 14.28, 16.67, on the face of it, they might not look pretty appealing. But the point is, hey, these are pretty popular numbers or popular percentage values, because if you just know up to 1 by 20, all right, these popular figures can be handled with ease. All right, from that perspective, you got to learn that particular table. I just illustrated why it is important to learn those percentage fraction equivalent either ways. So we'll see in the future, we'll see that, hey, okay, so knowing one side is enough, which means if I know 14.28% is 1 by 7, will that be good enough? No, it is also important that 1 by 7 means 14.28%. We will see that in a while. How it is important, we'll see that also in a while. Okay, and there are a couple of keywords. All right, now these are all must factors, must know factors. There are certain keywords, even we get into the core concept, certain keywords. Off is such an important word in a percentage. The word off is very important. See, it can be a long sentence. I've just taken a very short sentence to illustrate that fact. It can be a even very long sentence. What matters, what I'm trying to say is what comes immediately after. All right, whatever comes immediately after the word off, whatever comes immediately after the word off, all right, would become the base, benchmark, denominator. See, while doing a percentage calculation, what is the what is the kind of a structure that you get when you are writing a percentage calculation? This is the structure. You will have some numerator, you will have some number in the denominator into 100, all right, which becomes your answer. Ultimately, most likely, in all likelihood, this is the calculation that we get. So therefore, what is the denominator? This is the gold standard. All right, you are comparing numerator with the denominator. See, look, all right, if you just want to quickly understand, you might have got 83 marks out of 100. How did you write it? All right, you went on to write like this: 83 out of 100. All right, the paper was for 100 marks. This is how you wrote. Hey, you got 19 marks out of 25. All right, in one of the internals. How did you write? 19 out of 25. Hey, what is this denominator? All right, what is the number in the denominator? 25 or 100. These were the benchmark figures. You are trying to say that that was the base on which my performance is measured. All right, that is the base on which the performance is measured. Always remember, whenever you write something in the denominator, that is the gold standard for that question. That is the standard of measure. And what you are measuring numerator with that denominator, right? That's a whole point, right? Yeah, this clarity should be there. Fair enough. So now, it's coming back to the discussion. Immediately after, whatever comes immediately after off becomes the standard of measure, or it becomes the denominator. Fair enough. Let's take just two quick examples. So when we do the DI, I will illustrate more because there will be long sentences out there. But if this keyword is there, it makes the interpretation much more faster, much more quicker, right? So let's quickly understand. Hey, what is coming after off here? 50. What is coming after off here? 50. Therefore, 50 in the denominator. Off also talks about the direct comparison of two numbers. It also talks about direct comparison of two numbers. After off, it is 50. What is the number then I should compare with 50? I told you. So whenever you write something in the denominator, that becomes a gold standard. So if this is the standard, I need to measure something against this standard. Hey, what is that I need to measure? You got to measure 40. So author is saying that a 40 by 50 is what? All right, this is what this man is asking percentage wise. So into 100. Therefore, 51 times, 52 times, you say that, hey, this is nothing but 80%. So what percentage? 40 is 80% of 50. That is what we are expected to do. Hereafter, since we already know percentage fraction equivalent, hereafter, for the rest of our discussion, for the next 45 minutes, so when we already got this 40 by 50, put this in the simplified form in your mind, call it as 4 by 5. And from here, all right, even if you don't recall 4 by 5 immediately, bring it as 1 by 5. 1 by 5 is equal to 20%. So therefore, 4 by 5 is nothing but 4 times of 20%, which becomes 80%. See, this is how your mind is thinking. Even if you directly do not recognize 4 by 5, that's all right. Recognize what is 1 by 5, which is 20%. 4 by 5 would become 80%. My point is what? Hey, don't write this black box. box, right? Let's avoid this black box, which is unnecessarily tedious. What was the black box? This was the black box. What I wanted you to write when you looked at 40 by 50, I wanted you to write 80%. This is what the drill we were doing. I don't want you to write into 100 is equal to something. Might not be required there. Fair enough. Let's take a look at the second one. Let's take a look at here, the question out here. What percentage of 50 is 40? Right? What percentage of 50 is 40? So now you may say that, hey, after off, 50 is also after off, because you are looking for the keyword off. Okay, there is 50 is positioned after off. 40 is also positioned after off. Therefore, I use the word, hey, immediately after. All right, don't look for, there may be many numbers after that offer. It's a preposition. Technically, off is a preposition. It is positioning your base. All right, if you say this, what is this preposition doing? The preposition doing. It's trying to position your gold standard, right? Okay, so therefore you say that, hey, what is coming immediately after off? It is 50. Therefore, write 50 in the denominator. Write 50 in the denominator and put that 40 in the numerator. Direct comparison of two numbers. Therefore, with this 50, what you are comparing? You are comparing 40, which is technically 4 by 5. I told you already, we will not write into 100 every time. 4 by 5 is the fraction value. Fraction value is 4 out of 5 marks. Our percentage wise, how much? Percentage wise, it is 80%, because 1 by 5 is 20%, 4 by 5 is 80%. See, I'm avoiding this black box. What is that? 4 by 5 into 100. I'm avoiding this black box is equal to, I'm directly writing it as an 80%, right? Yeah, let's try doing that. Okay, that's the important of keyword off. Look for that keyword off in the percentage problem. Whenever you are dealing with the percentage problem, just quickly look if this keyword off is there. Then it's pretty sorted. So if the keyword off is there, whatever is coming after off, put that in the denominator. Put the other number in the numerator. Compare the numerator with respect to denominator. I hope you are getting this clarity here. Importance of keyword off. There is another important keyword here. There is another important keyword in percentage. Okay, we are fixing the nuts and bolts now, right? We are not getting into the problem. That's later. Once the nuts and bolts are in place, constructing an assembly is not a problem, right? You might have all the components. If the nuts, bolts are missing, fixing the components is a challenge, right? So what we are doing off, than, etc. is we are trying to understand the nuts and bolts. Then when we go to the word problems, that's an assembly. We will be easily able to fix the assembly easily, provided these nuts and bolts are in place, right? So we are here. Then let's understand the importance of than. So what does than do? Than is nothing but the difference comparison. First of all, whatever comes immediately after than, whatever comes immediately after than, whatever comes immediately after, because even after than there may be many other numbers that might follow, but look for whatever comes immediately after than. That should be positioned in the denominator, right? We already know the structure. There is a numerator, denominator into 100. I'm talking that becomes the benchmark. All right, therefore what comes in the numerator? Therefore, so whenever you're using the keyword than, it is the difference comparison. It is the difference comparison. With difference means what? Either you write more or less. Than is technically associated this word. Therefore, write the more or write the less. Don't write the other number directly. Fair enough. Let's understand this little better. A is 25% more than B. It's given. A is 25%. A is 25% more than B. Then B is what percentage less than A? So you may wonder, the number itself is missing. A is 25% more than B. Where is A here? Where is B here? Right? That doubt also you may get. So I'm talking two things out here at a time. All right, at a time. So let's put it something. Let's put it like this. To simplify it, maybe one stage you want me to simplify. Let's put it like this. 50 is 25% more than 40. Technically it is truth, right? It is truth. But you may wonder, how did you arrive at these numbers 50 and 40? Okay, so let's put it like this. What did your teacher say? Even if you want to make an assumption in the percentage, your teacher should have said that, hey, somewhere you can assume a number called 100. That much you will remember, right? So percentage goes with somewhere the assumption of 100. You can assume sometimes the 100. Again, the point is, which number should be assumed as 100? Whatever comes after off, whatever comes after than, again, whatever comes after, whatever comes immediately after off, or whatever comes immediately after than can be assumed as 100. Or it can be assumed. 100 may not be a suitable number every time, but in case you want to assume something as 100, again back to the basic. So what can be assumed as 100? Whatever comes immediately after off, or whatever comes immediately after than can be assumed as 100. All right, now that could be the nice way to assume an 100. So let's go here. This is an information. This particular portion is an info, that's an information. So what is coming after than there? So what is coming after than there? It's nothing but B. Therefore, B is 100. Take B as 100. Now you are fixing the dummy value of B is 100. Now what is A? More than. A is 25% more than B. What is 25% of 100? 25 itself. Therefore A becomes 125. That's precisely the reason why you took B as 100. Right? You didn't take B is equal to 72. Right? Because calculating 25% of 72 is 18. Would have taken some time. Right? Therefore you said that, hey, let the B be 100, because calculating 25% of 100 is very easy. Nothing but 25 itself. Even if I say that what is 23% of 100, that also becomes 23, right? So it becomes easier. So therefore you got the dummy value of A is equal to 125. You got the dummy value as 125. Fair enough, this should be fine. So you got the dummies in place. Now come to the question. All right, with the dummies in place, come back to the question. What is the question? B is what percentage less than A? Now look at this. What is coming after than? After than, it is A. Put that A in the denominator, 125. Put that fellow in the denominator. Now less means the difference between what? A and B. Difference between what? A and B. Difference. Okay, what is the difference between these two numbers? 25, because B is set at 100, B is set at 20, A is set at 25. Therefore what is the difference? 25. Simplify this becomes 1 by 5. That's a fraction form. 1 by 5 is the answer in the fraction form. What is the decimal form? This percentage form, it will become 20%. Therefore, if A is 25% more than B, then B is 20% less than A. Alright, then B is 20% less than A. Alright, yeah. So let's take a look at this. Is there a better way to do this? Yeah, there are better ways to do this. I will not take too many examples. Alright, you might have to carry on with too many examples out here. What is the better way to do this? Now listen to me. Okay, I spoke two things already. So one, whatever comes after than should be in the denominator. That should be very clear. And then whatever comes after of or than can be assumed as 100. In case you want to assume something as 100 in the percentage, look for these keywords and then take that particular number as 100. All right, these are the two aspects I clearly spoke about. Fair enough. Now let's also look at alternate way of doing the things. If the information with more is presented and the information with less is asked, right? You didn't understand, right? Okay, so what is information with more? All right, now look at the first line. Let's go back to the first line. All right, go back to the first line. That's an information, right? This is an information. A is 25% more than B. It's an information. Information has a word more. Right, now what is the question? B is what percentage less than A? Right, less is in the question. Right, this is a part of info, more is a part of info, less is a part of a question stem. There can be synonyms as well. More, or it can be increase, or it less could have been recognized as decrease. It's fine. All now all those kind of questions. Okay, now look at this. If the fraction form, if the more is associated with a fraction A by B, if the more is associated with a fraction A by B, if it is more, write plus. Just write plus. If more is associated with a fraction A by B, less will be automatically, less is written as, repeat this A as it is, repeat that A as it is. Now while you are writing in the denominator, write B plus A. Look at the sign between A and B. What is the sign between A and B? Plus. Therefore add both of them and write where? Write it in the denominator, which becomes your answer. Okay, I will repeat it again. So if the more is associated with a fraction A by B, alright, I will come to it. More has a fraction called A by B. So your answer, because your question has a less, alright, therefore answer to your question will be this A, you repeat it as it is, you repeat it. The denominator, don't repeat B, instead write it as B plus A. Where is this A coming from? Here. Where is that plus coming from? Here, right? Because more is associated with plus. Fair enough. Let's understand this question. Let's go to the first question out here on this note. Now look at this. What is the fraction associated with more? 25%. What is 25%? 1 by 4. 1 by 4. That's what I asked you to write. The fraction associated with more is 25%. What is the fraction form of 25%? 1 by 4. I wrote it there. Now look at your answer. Repeat this one as it is. Repeat this one as it is. What is 4 plus 1? 5. What is 4 plus 1? 5. Write that. That's your answer. Is my answer 20%? Yes, that's what you said before as well. What is 1 by 5? 1 by 5 is the fraction form. What is the decimal form of this number? 20%. Right? That is also fine. So now look at this. Second question. It becomes so beautifully well if you remember some things like this. Right? So when you are doing certain questions, it would definitely come much more handy when they authors think that, okay, I've created a pretty tricky question. I've not given a very convenient number to the kid. All right, let's see how the test taker will behave on this question. Take a look at this question, second one on the other side of the spectrum. So A is 28.57% more than B. Doesn't look pretty appealing. Even if you write B as 100, we told that, hey, after then whatever comes, treat that as 100. All right, 100 plus 28.75, it will look like now 128.75. All right, 128.75. Nobody likes this number. What is this 128.75? It's not very appealing to us. Fair enough. But if I take the fraction root, right? If I take the fraction root, what is 28.57? This coming is the information. Is this associated with more? Yes. Right. So therefore you write this as plus. 28.57 is 2 by 7. Today it might appear pretty tricky for you. I don't know, you are writing with so ease that 28.57 is 2 by 7. Yes, right, but I asked you to do that chart, right? 1 by 7, 2 by 7, 3 by 7. After doing this particular chart, you look at this number, your mind is excited. It says that, hey, it's such a lovely number has been presented in front of you, right? 2 by 7, that's what you write, more than B. Then B is what percentage less than A? Write it 2 as it is. Don't change the numerator. Don't change the numerator. Denominator, don't write 7 as it is. Instead, 7 plus 2, write it as 9. 2 by 9. We already learned that, what is 1 by 9? 11.11%. What is 2 by 9? 22.22%. That's your answer. Therefore, you say that B is what percentage less? It is 22.22% less. It's worth remembering this. Right, it is worth remembering this particular proposition. It's good, all right, no, because if you just remember this, probably some of the not so good numbers, all right, not so good numbers can be handled with ease. It's a not so good number from the layman's perspective, but from the learned man's perspective, in the sense learned with respect to the percentages, right? Well learned from the percentages. Hey, these are the welcome numbers. These are the welcome numbers. All right, yeah. So we should know, all right, when we do this chapter, these are pretty welcome numbers perspective. Great. All right, let's take a look at the other one. Less than, the keyword less. All right, now what is the information has a less on this? We can do pretty much as we did before, in the sense I go here, what is coming after than, it is B. I'll call the dummy value of B is equal to 100. A is 25% less, so therefore 25% of 100 is 25. Less means A becomes 75. It is not more, it is less. So A is less, smaller, therefore A is equal to 75. What are these? Dummies. You got the dummies for A and B ready. So you may wonder, sir, you are writing dummies here, so what if I change the dummy? It's fine, because change the dummy, relationship should be 25% less. You are change the dummies with respect to same relationship, because percentages are abstract, right? You have to remember that the percentages are abstract in nature. All right, therefore the dummies work. When the dummies work, when the required answer is not absolute, right? There is a difference between abstract versus absolute. It's abstract, right? Abstract versus absolute. Right, when the percentages are abstract, the answers, see, look at this, what percentage more? It's an abstract. Absolute means I want a number, then I want the actual numbers. If you want an absolute number as an answer, okay, that is 25 less. I'll assume that this question is to do with some apples, right? How many apples less, etc. Then you have to count and tell, right? Percentage on the other hand is abstract in nature, right? Yeah, so if you're talking from abstract perspective, dummies will work. So you should know when the dummies will work. You wrote the dummy value of B as something, dummy value of A as something. So will the abstract nature, all right, now is it abstract? Look at the question. Percentage, if the question is asking about what percentage, abstract. If it is abstract, answer required is abstract in nature. That's percentage, ratios, all these are abstract. If the answer required is abstract, you can use dummies. See, that's another thing that you should know, when to use dummies, when not to use dummies. It's not that whenever I want, I feel like using dummies. Not necessarily. You got to read the question. All right, yeah, good. So here I got my dummies, because the required answer is abstract. So B is 100, A is 75. Great. So now come back to the question stem, right? Let me come back to the question stem. In the question stem, more than A. What is coming after than A? What is the value of A? 75. Put that. more than, which means the difference. How much more? B is how much more? 25 more, because 100 minus 75, difference is what? 25. 25 by 75, all right, which is nothing but 1 by 3. So 1 by 3 with the fraction form. What is the percentage form? 33.33% to 2 decimal place accuracy. This is what you could have written there. Another point, okay, let's keep this in mind. So another way of handling this thing, hey, what if less is given as an information? In the information, they've spoken about the less, right? And in the question, all right, in the question, they are talking about more, right? When the less is given, how to arrive at more in the abstract sense. When the questions are of the abstract sense, when the less is given, how to arrive at more. Let's take a look at this, how to arrive at this. So less is of the form x by y, let's say. All right, the less is of the form x by y. Then more will be of the form x divided by less. Less means what? Write a symbol minus. Right, minus. Less is of the form x by y. More will be of the form x divided by y minus x. This y minus x. Right, y minus x. Don't change the numerator. Keep it as it is. All right. Let's take an example on this. Say same two examples so that you are seeing. Let's try them. So now what is the information? Let's come back to the question that we already solved. Let's come back there. What's the information related with less? A is 25% less. What is 25%? 1 by 4. The word is less. So that minus is a symbolic of stating that you are writing the lesser side, so that you don't forget what you are writing in the answer. Now the answer question is asking about more. When you are writing more, repeat this one as it is. Repeat this one as it is, right? And then 4 minus 1. What is 4 minus 1? Which is 3. Therefore you are writing 1 by 3, which 1 by 3 is nothing but 33.33%. the same 1 by 3 you had here. Pretty easy to write. If you have this mnemonic in your mind, just keep this understanding in your mind. It's so easy to write the question. Now look, it becomes all the more important when you have such numbers like, favored numbers in percentage. 37.5%. It's not very nice to write a 100 here, 100 minus 37.5. A will become 62.5. Doesn't look pretty appealing, right? Yeah, because it is 37.5% less. What is the number you should write for A? Then you should write 62.5. Doesn't appear pretty appealing, but 37.5. So not right now, but you would definitely know after some time. 37.5% is nothing but 3 by 8. Right, so I asked you to learn this. Hey, learn 1 by 8, 2 by 8, 3 by 8, or likewise up to 7 by 8. What is 7 by 8? 87.5%. Right, 1 by 8 is 12.5%. Do this chart. 1 by 8, 2 by 8, 3 by 8, up to 7 by 8. When I do this particular chart, so in between that chart, you will also get 37.5. So what is the value of 37.5? 3 by 8, fraction value. So write that here, 3 by 8. A is 3 by, now A is 37.5% less, nothing but 3 by 8. Write the more side, therefore your answer looks like, hey, copy this 3 as it is, don't change this 3. Don't change this 3. All right, so when you write the denominator, do this. 8 minus 3. What is 8 minus 3? 5. Write that portion. Hey, what is 3 by? That's your answer. In fact, this is your answer. This is the answer in the fraction form. Hey, what is this answer in the percentage form? 60%. Because you know that 1 by 5 is 20%. So therefore, all you come and write this as what percentage? Right? 60%. This is nothing but 60%. I hope it's making quite a bit of sense to you. So what I'm talking here is making some sense. All right. So my point here is what? Hey, knowing certain things is definitely important. If you know those things, all right, you can kind of work a little faster. So how these keywords than, how these keywords of kind of work, all right, it's knowing those things are very vital and relevant to us. There is another important, okay, before we'll do one application, and there is one last important thing out here. These are the 3 must know things of percentages, right? Yeah, so two of them I spoken about: importance of, importance of than, right? And then let's now do a couple of applications here, and then we will look at one last aspect of it. What is the importance of another third parameter? Once we finish these parameters, so these are the 3 key parameters you got to keep in mind. Thereby most of the questions, not only in percentages but also already in profit, loss, discount, or it could be on the SI, CI, in their data interpretation, they all would start appearing, seemingly falling in place. All right, let's take a look here. Keyword application. Okay, yeah, in sense whatever we did, I'm using both the keywords. If you look at this particular question, I'm using than on one hand I'm using off on the other hand, right? Beautiful question. I'm using both the parameters on this. How do I understand this question? Take a look here. If the salary of Ram is 28.57% more than Lakshman, then Lakshman's salary is what percentage of Ram's salary? Let me come to the question stem. Lakshman's salary is what percentage of Ram's salary? Technically, what is being asked? Number associated with Lakshman. After off, what is coming? Ram is coming. Therefore, Ram here into 100 is equal to what? This is what I wanted as an answer. This is what I need to substitute. But the point is, what is L and what is R? All right, now if I know my L and I know my R, all right, in the fraction form, I can tell the answer in the percentage form. This is what is expected here. So therefore, if the salary of Ram, all right, let's go back to the info. Therefore, let's go back to the info. Let's go back to the info. If the salary of Ram is 28.57% more than Lakshman, see again. So now writing is not pretty convenient. If you write Ram, Lakshman as 100, the salary of Ram is this much more. Therefore, you write this as 128.57%. Now, if I plug this as L and R, it doesn't make much sense to us. That's not the way to approach it. Again, listen to me very clearly. Listen to me. Okay, who is the benchmark here? After than, who is coming? Lakshman is coming. Lakshman is the benchmark. Even if you see an ugly number like this, 28.57%, write it as a fraction. What is 28.57%? 2 divided by 7. Out of which, what is your base here? Base is 7. Therefore, simply put Lakshman 7. Don't write 100. All right, 100 is what we learned in the school, because they used to give us nice numbers, 20%, 25%, 30%. Good numbers. They never taught us in the school giving 28.57%. Now it is important for us, right? It wasn't important then. Now it is important. Therefore, rather than calling after than, Lakshman is coming, rather than calling that as 100, I will say that let the value of Lakshman be 7. Fair enough. So how much more here? 28.57% more, which means 2 more. If this is 7, all right, now Ram will be, this is 2, 28.57 is 2 out of 7 into 7. See, now look at this. All right, 28.57% more means what? If Lakshman is 7, Ram will be 2 by 7 times of 7 more. 7, 7 cancel, it becomes 2. All right, therefore Ram, you will write it as 7 plus 2, all right, which would become 9. These are the dummy values. See, writing dummy values itself is a skill. If you write the correct dummy values, you get the answer faster. Let me repeat this once again. It is very, very important. Right now, what is the benchmark? Let's go to the information. Ram is 27 per this much more than Lakshman. What is coming after than Lakshman? Therefore, I have to make a suitable assumption for Lakshman. It is the benchmark denominator. Okay, now look at this fraction, 28.57%. What is this? 2 divided by 7. This is 2 divided by 7. Apply this for Lakshman. Whatever is coming in the denominator is this number. This for Lakshman. What will be Ram? The word is more. More means plus. More means plus. Simply add these two numbers, 7 plus 2. Call that for Ram. Therefore, 9 is for Lakshman is 7. If Lakshman is 7, then Ram is nothing but 9. So how did you get this 9? Because the word associated with more, 7 plus 2. All right, just add them up. 7 plus 2 becomes Ram. Did you get the dummy values for Lakshman and Ram now? Yes, Lakshman is 7, Ram is 9. Applied here. What is this Lakshman? 7. What is Ram? 9. Do I know the value of 7 by 9? Yes, you might know 1 by 9. 1 by 9 is 11.11%. Therefore, 7 by 9 is 77.77%. That is the required answer for this. Lakshman's salary is what percentage of Ram's salary? Roughly 77.77 or 77.78%. Good. Let's take a look at the second one. Out here. Another one out here. Yeah, if the salary of Ajay's salary, all right, now salary is repeated twice. Salary of Ajay is, remove this. If the salary of Ajay is 22.22% less than Bimal, now look at this, it is less than Bimal. So therefore, Bimal after than is Bimal. Therefore, write this as the fraction 22.22%, which would become 2 divided by 9. Okay, today you may not be very comfortable immediately, right? But definitely once you learn the chart, what I said, you would be pretty comfortable writing this number. You are writing it as 2 by 9. So this 9 becomes Bimal. All right, this 9 is Bimal. Now look at the word. Word starts off less. Less means minus. 9 minus 2. All right, now therefore you say that Ajay is nothing but 9 minus 2. Ajay is 9 minus 2, which becomes 7. All right, therefore, did you get the dummy values? Yes, if Bimal is 9, Ajay is 7. Question. After than, what is coming here? Ajay. Therefore, write 7 in the denominator. What you have to compare? The more. All right, no difference. Difference you have to compare. Whose salary? Bimal's. Therefore, write the difference. 9 minus 7, which is 2. Therefore, 2 by 7 times of 100. Right? What is 2 by 7? 2 by 7 is 28.57%. Therefore, you are trying to say that Bimal's salary is what percentage more? All right, it is 28.57% more. Pretty simple. All right, pretty simple and elegant questions what we are doing. Right? If you get the right understanding of this, so doing these questions is just a cakewalk. See, you don't write all of this. This is too much of writing. Right? So, very important thing. What did you learn? Hey, percentages should be looked as fractions. If you understood this, my bottom line, if you ask me what did I try to do so far, if you can understand percentages as fractions, it's very easier. All your working should happen as fractions. Your question will be percentage, your answer will be percentage, but your working is fraction. Your entire working is in the fraction form, right? So your start point is percentage, end point is percentage. Hey, what I meant, listen to this, right? Your start point is 28.57%, your end point is 77.77%. But what is there in between all of that? It is fractions only. Between all the stages, it's just a fraction. You started with 28.57, you ended with 77.77. But all in between is just a fraction representation. It's all the fractions, story of fraction, dealing with the fractions, interpreting the fraction, trying to make some sense out of it and try to arrive at the answer option, right? Yeah. So therefore, I emphasize this right in the beginning. Hey, percentages don't look like a percentages. Understand that we start the problem as a percentage, we do all the working as a fraction as much as possible, and we give back the answer, convert and give back the answer in the form of a percentage. Fair enough. All right, now that's about these applications of keywords. One last and important thing, percentage change. Right, last and important thing. So multiplier, it's very, very important. All right, now, so whatever we did so far, it is much more important than what we did so far. Let's take a look at this. Well, let's understand this. So multiplier is a concept associated with percentage change. Okay, what do you mean by change? Percentage change is nothing but percentage increase, or it can be percentage decrease. Now, to say increase or decrease, two things are required. One initial value is required, one final value is required. Right? Yeah, initial and final value. So naturally, all right, now, so what you learned in the percentage increase, I hope all of you remember this. Percentage increase is nothing but final value, because final value would be better. If you're writing an increase, what do you know? You looked at two values in front of you, final value appeared better. Therefore, you end up calculating what is percentage increase. Final value minus initial value divided by initial value into 100. That's how you calculated percentage increase. Hey, what if you wanted to understand the percentage decrease? Percentage decrease, already you looked at two values, that's the initial value and final value. You look at it, when you realize that initial value is better, finally it went on to become smaller. So therefore you write that percentage decrease is initial value minus final value divided by initial value into 100. You may wonder, sir, this is, we know from class 6 why you are talking about this. I'm coming to it, right? So what is important to me is percentage increase or decrease is calculated upon initial value. Be it increase or decrease, gold standard. What is the benchmark? The benchmark, which means comparison. You always compare the numerator with respect to denominator. Remember, be it increase, the concept of increase, or be it the concept of decrease, it is calculated upon the initial value. Fair enough, we understood this. Now listen to me. If there is a particular value, say there is a number called 80. Listen to me, all of you listen to me, carefully listen to me. If there is a value called 80, I said that, hey, why don't you increase this by 25%? Increase by 25% and tell me finally what it becomes. What is this percentage increase? I'm writing plus. Plus stands for increase. There is a number 80. Increase this by 25% and let me know what is the final value out here. Fair enough. Now listen to me. So if there is an increase already here, so if you are doing it in a school, this is what you will write: 80. Let 80 plus, let 80 plus 25% of 80 is equal to final value. Right? Yeah, this is what you would have done there, right? Then you will calculate 80. You will calculate. Already, some people will take 80 common between the two numbers. Then they will write 1 plus 25% is equal to final value. Yeah, we are coming there. So now let me write this as a fraction. I'm doing it very intentionally. 1 plus, right? Now look at this 25%. Fraction form of 25% is 1 by 4 is equal to final value. What did I do? I wrote this 25% as a fraction form, which became 1 by 4, right? So therefore you say that 80, take the LCM here. This bracket can be written as 5 by 4, which is equal to final value. Then you can calculate. From here it is simple. All at 4 ones are, this is 420 times. Right, yeah, 420 times 20 into 500. That's your answer. Great. All right, now that's not my worry. My worry is after reading this question, right, I read this particular question. There is a 80, which I want to increase it by 25% to arrive at the final value. Can I write directly this? All right, after reading this, can I write this? If I can write this, then I will be definitely gaining the speed and momentum. Naturally, you will be gaining the momentum if you could write it as 80 into 5 by 4 directly. Let's understand. Okay, is it possible? Yeah, of course it is possible. That's what is my importance out here. All right, let's see this. So first look at this 25%. Let's take a look at this 25%. Plus 25%. What is plus? There is an increase. Write it as a fraction form. Plus 1 by 4, always fraction. Any percentage you see, write it as a fraction. Okay, plus 1 by 4. Now what you do is denominator as it is, copy the denominator as it is, don't change. Now look at this, 4 plus 1, 4, there is a plus sign and 1, write that in the numerator, 5 by 4. Therefore 25% increase means 5 by 4th of the number. This 5 by 4 is called as the multiplier. This 5 by 4 is called as the multiplier. It happened. Now what you do is, what you should do, this is the structure. Initial value into multiplier is equal to final value. It is always the structure you should remember. That is why, that's why I said that percentage increase or decrease is calculated upon initial value, meaning multiplier should be always on the side of the initial value. This is the structure. Initial value into multiplier is equal to final value, right? So you understood that how I'm getting this 5 by 4 directly. Let me do a couple of questions just to illustrate this point now very clearly to you. Just to illustrate, let me do a couple more questions just to understand it better. Just give me a second, my friend. Yeah. Thanks. All right. Yeah. So let's understand this. So I took an example earlier. So we said that okay, there was a number 80. Let me take a different number. Say there is a number 120. I decided that I want to increase this particular number by say 16.67%. I want to increase this by 16.67%. Therefore, how does a final value look like? Simple. All right. Now, so my final answer will be 120 into multiplier is equal to final value, because this is the initial value what I'm writing here. 16.67%. What is that? You say that plus 1 by 6. What is the multiplier for this? 7 by 6. No plus. This is a multiplier. So what is that? 6, copy it as it is. 6 plus 1 is 7. All right. That is the multiplier. Multiplier should sit always on which side? Initial value side. What is the initial value? 120. Therefore 120 into 7 is the required answer, which is the final value. Simplification is simple. This is 6 one time, this is 6 20 times. Therefore 20 into 7, your final value is nothing but 140. Beautiful number, right? That is what you mean. On the other hand, now listen to me. On the other hand, say the initial value is same 120. Let us say there is a 120. This is the initial value. You decided to decrease this. By 16.67%. Decrease. This time you decided to decrease. What will be the final value? Naturally, it would be less than 120. You decided to decrease it this time. All right. So again, method remains same. It's a decrease. Decrease means minus. What is 16.67 fraction form? 1 by 6. This is a decrease. All right. Fraction related with a decrease. Multiplier related with a decrease. Simple. Denominator as it is. Don't change. Don't change your denominator, copy it as it is. Numerator 6 minus 1, because there is a minus sign. From 6 you started, therefore I'm writing it in this fashion. 6 minus 1. What is 6 minus 1? 5. 5 by 6. Therefore you are saying that the multiplier related with 16.67% is 5 by 6. 5 by 6 times of what? Initial value. Copy the initial value, which is 120, which becomes how much? The final value, right? So therefore you say that this is 620 times 20 into 5, which becomes 100, right? Okay. You might have got a perspective on this by now. You might have got a perspective. So what if sometimes, so let know, sometimes the reverse will come. I will come back to that. The reverse part, I will come back to that. I hope you understood the multiplier part very clearly. This is very important. This makes a lot of our questions much faster. All right, this makes us to solve a lot of questions much faster. Let's take a look at some of these examples here. All right, I will do a couple of examples. Our concepts is cemented. Okay, let's take a look at this. Original number 3000. Original number 3000. That's nothing but initial value 3000. Percentage increase 33.33%. He's asking that, can you tell me the final number? Final number is nothing but the final value, what I call is a per final value. Now look at this. It's given percentage what? Increase, right? Therefore plus sign. Plus 33.33%. Now listen to me very carefully. What is the fraction associated with this? 1 by 3. What is the multiplier associated with this? Copy this 3 as it is. What is 3 plus 1? 3 plus 1 is 4. This is the multiplier associated with this. What did we learn? We learned that, hey, listen, initial value into multiplier is equal to final value. That is the structure. That structure cannot be distorted, right? It is always initial value into multiplier is equal to final value. Hey, what is the initial value for this question? 3000. 3000, that's what is given. Original number is 3000. Hey, what is the multiplier related with this question? 4 by 3. What is this? This is the answer, which is the final value, right? Therefore 3000, 3 one time, 3000 times 1000 into 4, which has become 4000. All right, that is the required answer. Very simple. If you once you get that multiplier in your mind, life is sorted. Life is sorted. Now he's saying that, hey, initial value itself is a question, man. I don't know initial value. Then the final value is given to us. Fair enough. All right. So in the same structure, structure is the same. You have to give me 2 ingredients out of 3 ingredients. All right. Now what are the 3 ingredients for this? There is an initial value. There is a multiplier. All right. There is a final value. You give me any 2, I will be able to find the third one. What big deal about it? You can't say that I will give you 1, find the other 2. No, you have to give me 2, then I'll be able to find the other one, right? So 2 out of 3, any 2 is fine for us. All right, let's see here first. Increase is how much? 87.5%. That's an increase. What is 87.5%? Today there can be a feel of discomfort, doesn't look so nice to us. Fair enough. So today I will help you. So 87.5% is nothing but 7 by 8. What is this 7 by 8? This is the fraction. This is a fraction related with percentage increase. What is the fraction? Then what is the multiplier? Therefore copy this 8 as it is. 8 plus 7. What is 8 plus 7? 15. All right. Therefore the multiplier is 15 by 8. Multiplier should sit on which particular side? Initial value side, right? Correct. Initial value side. Put it as perspective. Initial value, don't know. That only I don't know. Initial value I don't know. What is the multiplier? 15 by 8 for this question. What is the final value? 135. Final value is 135. Solve it. You get the value of initial value 15 one time, 15 9 times. Therefore initial value is equal to 8 into 9. Alright, initial value is equal to 8 into 9, which is nothing but 72. You are trying to say that, hey, this was 72, which went on to increase by 87.5%. Therefore it has resulted in 135. Pretty simple one. So once you understand multiplier, these questions can be resolved pretty faster, right? So no, look at this. All right, now this question is simple. Without knowing multiplier also you can do. That's not the idea out here. But let's learn multiplier, because in some of the tricky questions, all right, it might help us, all right, because these numbers are pretty good, nice and fine numbers. Hey, what if the numbers are not nice and fine? So let's understand that how do you do the reverse conversion? Why? Because now this time the what is the percentage increase? That itself is the question mark. He's saying that, why don't you tell me the percentage increase? That itself is a question mark. School method. Let's do it by the school method as well first. Let's do by the school method as well. Let me clear the board. I need some space. Yeah. Brilliant. Okay, let's take this third one, right? Third one, 360, and there is another one which is 420. Let's take quickly all right now. So if you do the school method, what you will do, this is the initial value, right? Assume that, okay, you are going by the school method out here. Then how you would have gone through this? This is the initial value. Just give me a second, my friend. Thanks. Okay. Yeah. Now this is the initial value. This is the final value. If you go by the school method, what you have learned, when you want the percentage increase, final value minus initial value divided by initial value into 100. Right? Pretty simple one. So this is what you would have learned there. 360, 420. Okay, so therefore you apply this, that's nothing but 60, difference between them 60 divided by initial value 360 into 100. Leave this, it's a black box, at least take this 6 one time, 6 times, solid, therefore 1 by 6. So you can write this as 16.67%. Right, 16.67%. That's an increase. Okay, let us keep it for now. Let us keep it as it is. Let's do the reverse drill. Let's do the decrease drill as well for today. Let's do the decrease drill as well. Okay, I'm hoping that okay, you are all understanding what is this issue of multiplier here. Let me remind you again. So what is the multiplier thing? So you have initial value, you have multiplier, then you have the final value, right? This is the structure. Technically, this is the structure, all right, that you have at your hand. This is the structure. Coming to this, it's a decrease. This time we are doing a drill on the decrease. This is the initial value, right? And this is the percentage decrease. So what do you mean by percentage decrease? And final value is question. Right, if you have a percentage decrease, what is this here? Minus 1 by 7. What is the multiplier related with this? 7 as it is. Don't change this 7. 7 minus 1, put that in the numerator, right? That is therefore multiplier related with 14.28 decrease is 6 by 7. What all ingredients do I have? Initial value I have initial value with me. What is initial value? Initial value is 252. What is the multiplier? 6 by 7, which becomes what? Final value. Simplify this. Therefore, you say that 7 3 times 21, well, it's 7 6 times 42. Therefore, the result has become 216. 36 into 6, which is 216. Let's take a look at this question as well. Let's take a look at the second one. Initial value itself is questioned. Fair enough. There is no problem. So there is a decrease of what? 62.5%. What is the fraction form of 62.5%? It is minus 5 by 8, right? Minus 5 by 8. Therefore, what is the multiplier? Keep this 8 as it is. Keep this as it is. 8 minus 5, which becomes 3 by 8. That is the multiplier related with this. So how do you write the result? Initial value, don't know, because that's what you are trying to identify. Don't know. Multiplier is 3 by 8. Final result 111. Right, 3 one time, therefore 337 times. You write your result, therefore initial value is equal to 37 into 8. Right, yeah, that becomes your answer, right? So therefore you write this final result as initial value as 20 296. You write this as 296. Right, yeah, so that becomes your kind of result get going out here. All right, results get going here. Third also can be done in the similar fashion, but all right, more importantly, right, we learned about the importance from the beginning. If you quickly want to recap, we understood the importance of keyword of. If the long sentences, it makes a lot of sense there. So how this plays as a benchmark, the number what comes immediately after of, the number what comes immediately after than, that's nothing but the importance of keyword than, and the combination of both of them when we looked at some of the applications, right? And then finally we learned about the multipliers. If